Welcome pre-cal students to the homework help video, page 806, 1 through 21, odd, and 51 through 55. Let's go ahead and get started. For numbers 1 through, I'm not sure exactly, let's see here, numbers 1 through 11, we are going to write these vectors in component form, and then we're going to find their magnitude, okay? So here we go. Number 1. It's kind of funny. Number 1 is obviously already done for us. The initial point is here at 0, 0, and so that's all we need. Whenever we're writing a vector in component form, it just simply means that it should be written with its initial point at the origin, so it's already done. So you would write it like this: 3, 2. Okay, so there's component form of the vector, and then the magnitude would be, well, you square the 3 plus you square the 2, 4, square root of 13. There's the magnitude, okay? All right, moving on to number 3. All right, here we go. Let's see here. Whenever you're finding the writing a vector in component form, you take the terminal point, which is negative 1, 4, and you subtract from it the initial point, which in this case is 2, 2. Okay, so in this case, component form would be negative 1 minus 2, that's negative 3, and 4 minus 2, which would be 2. So component form of this vector would be negative 3, 2. Okay? The magnitude would be, well, we'll square the negative 3, that's 9. We'll square the 2, that's a 4. We'll add them together, and once again, we'll get the square root of 13. All right? Moving on to number 5. Okay, your terminal point is 3, 3. And your initial point is 3, negative 2. So the component form vector would be 0, 5. Okay, because 3 minus a negative 2 would be 5. So there's component form. And then the magnitude would be, well, you square the 0, square the 5, square root of 25, which of course is 5. Okay, so there we go. Moving on to number 7. All right, number 7, this is your initial point here. This is your terminal point here. So we have 15, 12 minus negative 1, 5. And so your vector for your component form would be 16, 7. 16, 7. All right, and let me grab my calculator here. The magnitude would be 16 squared would be, I guess I should turn my calculator on first. 16 squared is 256 plus 7 squared is 49. And so we would have the square root of 305. The square root of 305 is the magnitude, okay? Moving on to number 9. The terminal point is 5, 1. And the initial point is negative 3, negative 5. So there we go. And let's see, 5 minus a negative 3 would be 8. 1 minus a negative 5 would be 6. So component form would be 8, 6. The magnitude would be, square the 8, 64, square the 6, that's 36. Add those together, and you get 100. And the square root of 100 is 10. Number 9, 10. All right. Number 11. Here's your terminal point. Here's your initial point. So component form would be negative 8 minus 1 is negative 9, comma, negative 9 minus 3 is negative 12. So negative 9, negative 12 is component form. Now the magnitude would be, let's see, square the 9, that would be 81. Square the 12, that's 144. Add those together, and we get 225. Now that should be a perfect square, I believe, and it is. So the square root of 225 is 15. So the magnitude would be 15. All right, let me get a drink here real quick. Okay, now what we're going to do is we're going to take this picture and we're going to give a visual of whatever we're asked to do. For example, on number 13, they want negative v. Now think about that for a second, students. Pretend for a second that v was, just pretend that v was 2, 4. 2, 4. Pretend that's where that point is, okay? So it'd be written like this. Here's v, 2, 4, okay? Now we're just making that up. Now, if I said negative v, you would take a negative sign like a -1 and multiply it through. Just like if it would have said 2v, then you would take a 2 and multiply it through. So, if there's a negative sign here, multiply it through, we get -2, -4. So it'd be -2, -4 down here. All that I'm trying to show you is when it comes to a visual problem in which we're not actually using numbers, you're going to give me a picture of what this is saying. Whenever it's a negative sign, it means you totally switch direction. So it was going like this. So negative v would just be like this. And actually, I can do a better job than that. Let me go like this and go like this, 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 and this. Okay, here's the vector right here. There's the same vector, identical. And what we do is we take that vector and we will turn it. Hopefully it's pretty much similar. Well, it was anyways. And now we put it right there. Okay, that's what negative means. You go completely the opposite direction, okay? So there's a picture of negative v. This is v, this is v right here. Negative v is like this, okay? Number 15, okay, u plus v. Now we know what this is. You guys should not really struggle with this at all, okay? We learned this already in our notes here. U plus v means that we are going to, you could take this vector here if you wanted and pick it up and put it right here, just like that, okay? And then we draw this line here, and that, students, is, let's get rid of this red vector here, that is the resultant, or the vector you get when you take u plus v, okay? Or another way to have done it was this. You could have taken this vector here and put it here, like this, and then put another vector here like this, and then it's the diagonal from here to here, which is the exact same thing I just had, okay? So there you go. This vector right here, we would call that vector u plus v. This vector right here, okay? All right, number 17. Okay, now, just like in normal common sense math, we're going to do our multiplication first. So we have 2v, okay? So I'm going to take a line right here, this vector, start here, and go like this, okay? Now I'm going to take that, I'm going to put it like this. So there's a picture of 2v. Got it? So now I have v from here to here, and then v from here to here. So the whole vector is 2v. Then I'm going to add u to that. Well, if I add u to that, remember what to do. I pick up this vector here, and I put it on the end of 2u right here, or 2v. And so here's your new vector right here. Right here. There we go. Okay? Now another way to do that, if you wanted to do it differently, would be this. You could well, it'd be the same thing as leave that vector there, and then we could also draw this vector here then you have your parallelogram, so your other vector starts here and goes here. That's the exact same thing, okay? So this vector right here, I'm going to highlight it for you. This vector right here is the answer. That vector right there is a picture of 2 or u plus 2v, okay? U plus 2v, okay? Let's go over it again. I multiplied v times 2, so here's v, then another, that's 2 v's, and then I added u. Well, here's u, so I put u right here, going up this way, and then here's your answer right here. Okay, moving on to numbers 19. Okay, we're going to do these three things very quickly. So for number 19, we're going to take u plus v, so u plus v would be let's see, 2 plus 1 is 3, and 1 plus 3 is 4. So 3, 4. Okay, let me check the answers here. Yep. Okay, then we have u minus v. So that's going to be 2 minus 1. That's 1, and then 1 minus 3. That's negative 2. So 1, negative 2 is u minus v. And then lastly, we have 2u minus 3v. Let's see. 2 times u would be 4, comma 2. And then minus, take a 3 times v. That would be 3, comma 9. Okay? And then subtract those two. 4 minus 3 would be 1, and 2 minus 9 would be negative 7. And that is the correct answer. Okay, moving on now to number 21. Alright, let's see what we have here. Okay, u plus v. Alright, u plus v would be, well, negative 5 plus 0 is negative 5, and 3 plus 0 is 3. So negative 5, 3 for number 21. And then we have u minus v. So u minus v would be same thing. Negative 5 minus 0 would be negative 5, and 3 minus 0 would be 3. So negative 5, 3. And then letter C, 2u minus 3v. Well, 2 times u would be negative 10, 6. And 3 times v would be 0, 0. So obviously your answer would be negative 10 minus 0, negative 10, and negative 6 minus 0 would be negative 6. Okay, and let me check that real quick, and yes, that is correct. Actually, it would be a positive 6 here, because we have a positive 6 here, so 6 minus 0 would be 0. Okay, moving on to number 5, 51. Now let me quickly glance in the book here and see what the directions say for numbers 51, 53, and 55. Okay, for the directions say for 51, to find the component form of v given the magnitude and the angle it makes with the positive x-axis. Okay, so here we go. We have a vector that has an angle of 0. Alright, there we go. So our vector has an angle of 0. So that means it's going to lie right here on the x-axis. And we know it has a length of what? 5. So what's component form for this vector? Well, guys, think about it. Is the initial point already at 0, 0? Yes. How long is it? 5. So what's this ordered pair right here? This ordered pair would be 5, 0. So the component form would be simply be 5, comma 0. Okay, that would be component form. Okay, moving on to number 53. Number 53. Angle 150. Let's go ahead and draw this here. That's a really good drawing, isn't it? Let's try that for the third time. That's even worse. There we go, and there we go. Now we're going to rotate 150 degrees, So there we go. So here's our vector, okay? There's our vector. A very poorly drawn vector, but nonetheless a vector, okay? And that vector has a length of 7/2. So 7/2. So we want to find this ordered pair right here so that we can write it in component form. So to find this ordered pair is over x and is up y. So we know it's over so far and we know it's up so far. Well, guys, we have a right triangle, and within that right triangle we have 30 degrees right here. So we can very easily find these missing sides quickly, okay? It wouldn't be difficult at all. So with that in mind, here we go. Let's go ahead and find, we'll call this our x because we're going across this way, and we'll call this our y. So we can say the cosine of 30 equals adjacent over hypotenuse. So multiply both sides by 7/2. 7/2 cosine of 30 equals x. And the cosine of 30 should be one of our special angles. I'm trying to see what that is real quick. Square root of 3 divided by 2. So we have 7/2 times square root of 3 over 2 equals x. So we would have 7 square root of 3 over 4. Okay, now students, listen. We know the ordered pair is here, so if the ordered pair is over here, we know the x is going to be negative because we're going from here over to here. So my vector so far in component form is negative 7 square root of 3 over 4. That's your x value right here, okay? Over to the left. Now let's find the y value going up. Okay, so we're going to use sine of 30 equals opposite over hypotenuse. Multiply both sides by 7/2. And then we'll take the sine of 30 and we'll get 1/2. So 7 over 2 times 1/2 equals y. So we'll get 7 over 4. Now that's going up on the x-axis, so that'll be a positive 7 over 4. So there we go. This vector right here, in which we were given the angle that it formed with the x-axis and its magnitude, the component form would be this right here, okay? Let me check the back of the book real quick, and yes, that is correct, all right? Number 55. Looks like the same thing, again, 150 degrees, so pretty similar to the other problem. So we're going to rotate 150 degrees like this. Here's our vector right here. Try to draw this one a little neater if at all possible. There we go, a little better. And let's see what we have here. Okay, the magnitude is 3 square root of 2. Okay, so we want to know what this ordered pair is right here, x, y, to find the component form, okay? So we know we're going to go down like this and then over. So this would be 30 degrees because this was 150, and this is my x and this is my y. So here we go. Cosine of 30 equals adjacent over hypotenuse. Multiply both sides by 3 square root of 2. So 3 square root of 2 cosine of 30 equals x. And of course cosine of 30 is, we have 3 square root of 2 over 1 times square root of 3 over 2 equals x. And so we would have, let's see, remember there's a 1 in front of this radical here, so we have 3 times 1 is 3, 2 times 3 is 6, square root of 6, over 1 times 2 is 2. Now students, please remember you don't reduce an inside number with an outside number, so it stays just like this, And remember, we're going from here over to here, so that's negative to the left of the x-axis. So far, our component form is negative 3 square root of 6 over 2. Okay? Now let's solve for y using sine. So sine of 30 equals opposite over 3 square root of 2. Multiply both sides by 3 square root of 2. 3 square root of 2 sine of 30 equals y. And of course, sine of 30 is 1/2. So 3 square root of 2 times 1/2. You can really put this over 1. So we would get 3 square root of 2 over 2. Okay, and that's positive because we're going from here up to this point here. So 3 square root of 2 over 2. Okay, so there is your component form. Okay, so really not too difficult. Let me check the answer real quick and make sure it's correct. And yes, that is correct. Not too difficult. Hopefully this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.